Hubert Mach Thaxton, black theoretical physicist. Born 1912, died 1974. Hubert Mach Thaxton did pioneering work in theoretical nuclear physics, performing research that helped explain the forces that hold atomic nuclei together. A teacher of both physics and mathematics, he also did applied research in acoustics and electronics. Hubert Mach Thaxton was born in Virginia on December 28, 1912. He attended Howard University, earning his Bachelor of Science degree in 1931 when he was only 18 years old. He earned a Master's of Science degree from Howard in 1933 for a thesis entitled The Reflecting Power of Mercury. Thaxton then entered the graduate program in physics at the University of Wisconsin, where he earned a master's degree in 1936 and a doctoral degree in 1939. His dissertation was entitled Scattering of Protons by Protons. Thaxton's doctoral dissertation and the majority of his early scientific work was in the area of theoretical nuclear physics. His work addressed an important question about how nuclear forces bind protons and neutrons into the nucleus of an atom. Electrical forces between positively charged protons should cause them to repel each other, yet in the atomic nucleus protons exist very close together. At the very close range of the atomic nucleus, the strong nuclear force that attracts protons is more powerful than this repulsive electrical force. Yet over a distance larger than the size of the nucleus, this strong nuclear force must be insignificant. Otherwise, atoms will be overcome by the strong nuclear attraction and crunch into each other. Electrical and gravitational forces have a simple mathematical dependence on distance. That is, the force decreases with the square of the distance. Nuclear forces, on the other hand, have a much more complex dependence on distance and other factors. Thaxton addressed this problem on dependence. To find this dependence, nuclear physicists perform scattering experiments. They accelerate subatomic particles, protons in the case of Thaxton's work, to a high energy and aim them at target particles. In Thaxton's work, the targets were either protons or neutrons. By studying the scattering of the particles after the collisions, physicists can deduce the forces acting between the particles. Thus, the collisions are actually near misses, in which the distance of the closest approach is related to the type of interaction and to the energy and therefore speed of the incoming particle. Hence, the work must be done for a wide range of different interactions and energies. Because this work requires both elaborate experiments and difficult mathematical calculations, there is a division of labor between theoretical and experimental physicists. Thaxton did the theoretical work. He performed the detailed calculations needed to deduce the nature of the strong nuclear forces. Comparing the results of experiments and calculations for a wide variety of energies and possible strong nuclear force laws provides insight into the nature of the strong nuclear forces. Thaxton's work with proton-proton and with proton-neutron scattering contributed to our current understanding of the strong nuclear force that binds the nuclei of atoms together. After earning his doctorate, Thaxton became professor of physics and head of the physics department at the Agricultural and Technical College of North Carolina, now North Carolina Agricultural and Technical State University in Greensboro. In 1945, he left North Carolina for New York City, where he was hired as a lecturer in mathematics in the evening division of the City College of New York. Thaxton worked concurrently for various companies, performing physics research with industrial applications. His employers included International Electronics, the Solar Manufacturing Company, Sperry Gyroscope Company, Tube Deshaussmann Corporation, Sylvania Electronic Company, and various divisions of Engelhard Hanover Incorporated and Engelhard Industries Incorporated. Thaxton also taught at Walter Henry Junior College. Thaxton held his position at the City College of New York until 1969, when he was denied tenure. He charged the college with denying him tenure because of his race. According to the New York Times, a hearing on this issue was held at the New York State Division of Human Rights on September 23, 1969. Thaxton's lawyer stated that in 1945, Thaxton had been hired as a lecturer, which is generally of low academic rank, and that he had not been promoted in over 20 years. City College claimed that Thaxton was not qualified to teach advanced mathematics courses. The college then offered to grant him tenure if he would take a mathematics competency exam. Thaxton refused. He argued that he should not be required to take a competency exam unless all the other faculty in the department were also required to take a similar exam. He felt that his advanced degrees and his original publications should be considered evidence of his competence. Thaxton's work in nuclear physics came to an end after the mid-1940s. Much of his later work was of a directly applied nature. This applied work included research in optics, acoustics, and electronics. D.A. Edwards, a colleague of Thaxton's during the 1940s, recalled that Thaxton had designed a type of circular slide rule, which would have been a valuable computational aid in the days before calculators. Thaxton authored a number of publications, including one with A.S. Eddington, the prominent British astrophysicist. It is not known whether Thaxton was ever married. Citations are in the description.